So push and pull. So oceanic crust becomes denser and sinks as it cools and moves away from divergent boundaries. So it's hot when it starts, and then it cools, and over time it cools and it condenses more and more. Now, ridge push occurs as the older, denser portion of the seafloor sinks and the weight of the uplifted, less dense ridge pushes the oceanic plate toward the trench formed at the subduction zone. So basically, if we have our sort of our mid-ocean ridge here, what you have here with ridge push is this downward force from all this material built up at the ridge pushing down on the slab. Now, in slab pull, the weight of the relatively cool, dense subducting plate pulls the trailing slab into the subduction zone, much like a tablecloth slipping off the table can pull articles off with it. So if you think about this slab, it's being pushed from the mid-ocean ridge towards the subduction zone. Well, the subduction zone, once this first bit of the plate sinks, it basically pulls the rest of it with it. So that is our slab pull. So as it starts to sink, it just pulls everything else with it. Now, this is likely more important than ridge push. Okay. So this whole idea of this subducting into the plate, kind of pulling the rest of it down with it, is probably more important than the ridge push. Now, in a diagram, what this looks like is basically we have our convection currents kind of coming up this way, going out. We have our ocean ridge here where the crust is being split. And then we have this ridge push that is pushing down and out from that ocean ridge. And then at the trenches, again, you have this plate being subducted. So this plate is basically sinking back into the mantle. So this plate is sinking back into the mantle, and it's basically pulling the rest of the plate along with it because this is still connected.